So now let us calculate what should be the maximum and minimum values of local oscillator frequency when high side injection is used and when low side injection is used. So let us first do the calculation for high side injection. Let us calculate what should be FO max. FO max in high side injection will be Fs max plus IF. That's the formula for FO. In this case, FO and Fs both are at its maximum values. Fs max is nothing but 1650 kilohertz. IF is a constant intermediate frequency value which is 455 kilohertz. So if you solve this, FO maximum comes out to be 2105 kilohertz. Okay, next let us now calculate FO minimum. FO minimum will be Fs minimum plus intermediate frequency. Fs minimum is 540 kilohertz and IF is again the same constant value of 455 kilohertz. And if you solve this, FO minimum comes out to be 995 kilohertz. Now if I find out the ratio of Cmax by Cmin required for the generation of FO in local oscillator, then as we can see that in the previous case, FO max square is inversely proportional to Cmin and FO min square is inversely proportional to Cmax. So in this case, if I divide FO max square upon FO min square, if I take the ratio, you can see when you take the ratio, Cmax will go in the numerator and Cmin will remain in the denominator. 2 pi square and L will cancel out. So it will come out to be Cmax by Cmin. I repeat, when you take FO max upon FO min, Cmin will go in the denominator because FO max has Cmin in the denominator and Cmax will come in the numerator. So that's my complete expression. So going back to the current discussion, Cmax by Cmin will be equal to FO max square upon FO min square. FO max is 2105, FO min is 995. If you take this ratio for high side injection, this ratio will come out to be 4.475. Let us now do the similar calculation for low side injection. So let's do it for LSI now. For LSI, my FO will be Fs minus IF, and here I am finding the maximum values. So FO max will be 1650 kilo, which is Fs max, minus IF, which is 455 kilo. And now when you take the difference, it comes out to be 1195 kilohertz. Let us now calculate FO min. FO min will be equal to Fs min minus IF this time. Fs min is 540 kilo minus 455 kilo, and in that case FO min comes out to be 85 kilohertz. So if I now take the same ratio of Cmax by Cmin, FO max square upon FO min square, this time if you take the ratio 1195 kilo upon 85 kilo, you will see that the ratio comes out to be 197.65. Let us now draw the final conclusion and justify why HSI is used over LSI. The ratio Cmax by Cmin in HSI comes out to be 4.475 and the same ratio in LSI is 197.65. So in HSI, let's say if my Cmin, if I'm using Cmin equal to 1 microfarad, then Cmax which is required is simply equal to, you can see Cmax will be simply 4.475 into Cmin, and that will be 4.475 microfarad. So the variable capacitor that I needs to change its value over the small range of 1 microfarad to 4.475 microfarad. Whereas the same calculation on the other side, if I take Cmin equal to 1 microfarad, then Cmax now will be 197.65 times Cmin. As you can see, that is available from the ratio, and therefore Cmax in this case will come out to be 197.65 microfarad. So you can see the variable capacitor that I will need must have the range of capacitance varying from 1 microfarad to 197.6 microfarad, which is almost 200 microfarad. So here the range is approximately from 1 micro to 4.5 micro, and here the range is 1 micro to 200 micro. And as you can see, in case of HSI, we can use a very simple variable capacitance device which gives us the variation over a small range of 1 to 4.47 microfarad. Whereas in case of low side injection, you will need a variable capacitance device giving you the variation to a very large range, and this is something very difficult to achieve. A very famous variable capacitance device is the varactor diode, which cannot give us the variable capacitance to very large range of 200 microfarad, something which is required in low side injection. And hence we conclude that we use high side injection in all practical AM receivers. But please remember that FSI, when you use high side injection, was defined as Fs plus twice IF. The same FSI when you use low side injection, so this is for high side injection, and when you use low side injection will be defined as Fs minus 2IF. So that's a difference. So if in the question it is mentioned that the receiver is using low side injection, then you have to be very careful in calculation of FSI. In that case, FSI will be Fs minus 2IF. This is because of the different definitions in case of LSI compared to HSI.